All right. Hi, everybody. Good morning. So, you got the title up there. You know where you're at. You know if you're in the wrong place or the right place. Let's get going. So, I'm going to start this morning a little unconventionally. I'm going to start this way because I've been thinking a lot about David Bowie recently. I don't know if it's because of his passing this last year. It just kind of struck a little close to home. But it got me thinking, he was an artist that I truly and deeply respect. And you may disagree. You may not like his style or his music or his pop music at large. But he was important because he managed to stay relevant for a half century. And he managed to stay relevant, I think, by reinventing himself every few years. Reinventing himself as Ziggy Stardust or Aladdin Sane or Jareth the Goblin King, right? All pretty cool stuff, but it's that change that kept him relevant in society. And I think that there's a universal truth in that in order to remain relevant, one must reinvent oneself. And this truth isn't relevant just to us as people or our cultural icons or our stars and celebrities, but it's equally true for technology as well. You know, for us as players on the technological landscape, on the technical landscape, we need to see reinvention. We need to see that little spark of magic rekindled every few years. And there's few technologies that I can think of that do that better than the web. Whether it was like kind of that start, the origin story there as ARPANET and some weird second season of Lost Corner of the government where they were essentially trading documents by sending tables and H1 tags and the occasional blink or marquee tag over the wire, to a little bit later, kind of there at the turn of the century, where DHTML and this thing they called Web 2.0 transformed those documents into applications that lived inside of our browser. And so we weren't just reading things anymore. We weren't just consuming information, but we were actually interacting with it. We were trading gestures and trading dollars and really just completely changing the way that we interact with that browser. And then it happened again when, to their credit, Apple popularized the mobile browser in kind of 2007. And all of a sudden, those applications that were on the desktop moved into these things, right? These tiny little devices that themselves are not only providing access to the same applications, but now they're location aware. They are spatially aware through the accelerometer. They're connected to the address book or the calendar or the camera or streaming video or any of the other different device capabilities that we've come to expect out of our phones. And so then it was just a little bit later in 2009 when folks like Brian LaRue and Jesse McFadden, who invented PhoneGap, right? And these guys were essentially presented with the challenge of saying, how do we make the web relevant and reinvent itself again? And so PhoneGap was quite literally bridging the functional gap between the browser's capabilities and the phone's capabilities, the browser's limitations and the phone's capabilities. That was a significant reinvention again. And now I believe that we're at another inflection point here in 2016 where consumers' expectations of what phones and what the browser is capable of and what apps are capable of has changed a little bit. There's a higher level of expectations about performance. We also expect when we interact with our apps that they have a certain design language that fits with the tribe that we've ascribed ourselves to, whether that is iOS or Android or Windows. We expect text to look a certain way. We expect design patterns to operate in a certain way. And so we're at a moment where we need to reinvent the web again. And it's critical that we do that because there are a lot of developers using JavaScript today. JavaScript is used more than any other language out there today. That means that there's a lot of expertise that is locked up there in that red bar. And we don't want to lose that. This comes out of a Stack Overflow survey that was just released this last month. And it's not just that JavaScript is being used in browsers, it's also the dominant technology for cross-platform development. Now, I am excited, you are excited, I know we are all super excited at the prospect of Xamarin and Microsoft doing great things in the very near future. But that does not diminish the fact that there are a lot of businesses that are making a significant bet on JavaScript as a cross-platform development tool because of its promise to leverage 25 plus years of web expertise and web development that is bound up in Stack Overflow questions and tutorials and libraries and frameworks that we can all leverage to deliver those apps more quickly at lower cost and reappropriating the same skills that we've all kind of developed over the recent years. And so what I'm going to do today is I'm going to do what I think the web does best. I'm going to bring people together. And I'd like now to invite into the stage Max Lynch of Ionic, who is building a JavaScript framework that starts to solve some of the problems of adapting to those different platforms and different design languages. Max, welcome up. Awesome. Hey, Max, man.
How's it going?
It's going really well.
It's awesome
I'm on stage,
to be here.
you know?
Yeah.
All right. So, Max, let's talk a little bit about Ionic and just kind of level set with folks what your organization is all about, what your framework is all about.
Sure. So basically, Ionic has given all these web developers who are used to building, apps for the desktop, et cetera, has given them components that fit the standard mobile user interface in a way that uses the exact same technology that they've come to know and love and use for the last, several decades.
Like JavaScript.
Like JavaScript and HTML and CSS.
Right.
We've also focused intensely on making sure those things are performant because it turns out that building web content targeted at these memory and resource-constrained devices is not relatively straightforward. So we've focused a lot of effort on building mobile components that look and feel good across all the devices that you want to deploy to.
Yeah. I think one of the significant things here is that, just like the web reinvented itself again and again and built upon itself, I think that one of the things that attracts me to Ionic is that it is itself building really kind of on the shoulders of giants in so much as it's building on top of the framework that Cordova provides, which itself builds on top of JavaScript and TypeScript, which itself builds on top of all of the history that came before it. And I think there are a lot of contributors that make the Cordova ecosystem more reliable and more mature than really just about anything else out there for cross-platform development through contributions from folks like IBM, Google, Adobe, SAP, all of these contributing to kind of bridging the functional gap there between what is there in the browser and in a reliable and kind of really enterprise-ready way, what the application needs to be able to do from a native API standpoint.
Sure, the Cordova ecosystem is incredible. Anything that you want to do from a native functionality standpoint, there's a plugin for it. Amazing corporate sponsors helping making Cordova better every day.
Yeah.
And the other really cool thing that we're going to talk a little bit about today is how Ionic and TypeScript, this future of JavaScript with amazing additional features, is adding a bunch of really awesome capabilities into the web development stack, including things like templates, code snippets, cross-platform debugging right in the IDE, and things that I think everyone here has come to know and love with the Visual Studio toolchain, things like IntelliSense and auto-completion that just work really, really well.
Awesome, awesome. Okay, well, so let's actually, we've tempted them enough here. Let's actually kind of jump into it. So for our demo today, what we're going to be using as kind of the vehicle for demonstration is a conference app that we built for Build 2016. This conference app was built using Cordova, Ionic, TypeScript, and Angular 2. It's important to note that we're using Ionic 2 beta and Angular 2 beta. And so in a lot of ways, some of the features that we're looking at today, while you can use them today, are roadmap features. And so it's a bit of a glimpse into what's possible in the future as well. All right, cool. So with that, I'm going to switch over to my machine here. We're going to switch to machine number 6. All right, so we're beginning today on the Mac because we're going to be using Visual Studio Code, Microsoft's lightweight cross-platform code editor. But I want to give you guys a quick view at what the actual user experience of the app looks like. So what I've got here is I've got a little iPod Touch, and in it I've already preloaded the build app. So here it is right here. I'm going to tap on it. And immediately coming up here, you see that we've got something that looks pretty familiar. It looks actually kind of like an iOS app. As I scroll down through it here, oops, I've already got some filtering on. We'll take some of our filters off. There. As I scroll through it, I've got pretty darn good performance coming out of this. It's essentially a list of sessions, and as I kind of swipe through those sessions, we go from 11 to 12 o'clock. You can see that the time sticks there at the top real nice like. I can go over here into my list of favorites, and these are a list of sessions that I have starred. In order to get to kind of get a session to appear over there, I'm just going to swipe left, hit favorite, and I get a nice little alert box here in the style of the iOS design language that says favorite added. You already saw over here that we could adjust to a list of, use a filter to filter it down to only show, I don't know, main theater sessions here, right? And so now it's just a list of main theater sessions. And then, of course, I've also got a slide-in menu over here on the side where I can navigate to speaker, schedules, map, about. I can also log in, right? And that's going to give me access to 3 different providers, Facebook, Twitter, and Google. All right? So everyone feel like you got a pretty good idea of how that app's put together, how it feels? Yeah, excellent, cool. All right, so now that we know what it looks like, let's actually look at how it was built, right? So as I said, I was going to start in VS Code. And let's begin by talking a little bit about the project structure. Let's just orient ourselves into the directory structure and what's going on here. So let's start with app here, right? This is borrowed from Angular 2, right?
Yeah, so with this new generation of JavaScript and Angular 2, we tend to work in a folder that has our pre-compiled assets that then get bundled up into underlying code that's actually going to run. So in this case, our TypeScript and our views, our templates, our styles, they live in this app folder. And our build process actually goes and compiles this TypeScript down into ES5 that most browsers understand today. Yeah. So the really nice thing about this is we can use future-focused features from JavaScript, but backport them to the actual runtime that the browsers have.
Totally, totally. And so once that all gets compiled, right, by Browserify and by Cordova and all that, it's all going to get dumped into this dub folder down here in the bottom. Because in the end, what a Cordova application is a web application that has been wrapped inside of a native wrapper and then installed on the user's machine. So when the Sass is compiled, when the TypeScript is compiled down to JavaScript, all of that will go into that dub folder. Now, this feels a little abstract, maybe it is, and so let's look at a schematic of it to see how that actually goes together, right? So we'll switch on back over to number 5. All right, so help walk us through this.
Yeah, so the really cool thing about Cordova is we spend most of our time building our app in this open web stack. We use HTML, we use CSS, we use JavaScript. In this case, we're using TypeScript to compile down to JavaScript, but basically just kind of open web standards that every web developer, every web designer around the world already knows. And Cordova takes this web code and bundles it into the native project and SDK runtime needed for that actual platform. So if we're building,
stamp out a project, basically, right?
Exactly.
Or generate a project, even more accurately.
So it'll give you an Xcode project for iOS. It will give you an Android project for Android, and then Visual Studio project for Windows Universal Apps. So, but in each one of those projects, the vast majority of the code that we wrote is this cross-platform web content.
And you never have to actually open up the Xcode project or the Android Studio project, or for that matter, I guess, even the Visual Studio project. You can do all of this, whether it's from VS Code or from Visual Studio IDE, and build for all 3 platforms.
Yep, and this is what people tend to love about Cordova, is that they're able to really spend most of their time building something once and deploying it for multiple platforms. And with Ionic, one thing that we've made sure is that they can also get the proper user look and feel for each platform, which was not necessarily possible before with vanilla Cordova and PhoneGap.
Yeah. All right, so that gives us a good idea of kind of what the build pipeline looks like. Let's zoom into actually like one of these native apps, whether it's the Windows Universal app, the native iOS app, or the Android app. The runtime architecture of all three of them is going to look pretty much the same.
Yep. So this is the cross-section of your bundled Cordova app. Underneath, we have the native SDK and native plugins. And the really important thing to remember about Cordova is you're building a native app. You have access to the full native power of the device underneath. You can access Bluetooth, take pictures with the camera, Touch ID on iOS, et cetera.
Yep.
And then Cordova acts as this,
it's a go-between.
It's a go-between, a shim,
right?
a bridge that translates your JavaScript calls into the native code underneath and then returns the results back to you. So as a web developer, you can write camera.getPicture. Cordova will send that down to the camera plugin, and it will, do the proper one for Android, the proper one for iOS and Windows, and then give you back this camera picture. So you don't really need to care about the underlying platform at all. It pretty much just works.
So above that, we've got Angular and Ionic, which are essentially our JavaScript frameworks that are imported just like for any other web application, right? In this particular case, we just happen to be using a framework, Ionic, that is designed specifically for execution on mobile devices, right?
Yeah, so the really cool thing about Angular and why we built Ionic on Angular is it lets you build custom web components. So a web developer could write an HTML tag, so ion-tabs, and it would generate this complicated mobile user interface underneath. But to them, it still felt like writing HTML. They could customize it with CSS. It was just really, really awesome way to add these cool, powerful features to HTML.
Yeah, all right, so like to sum it up, in the end, we're getting really awesome mobile controls, optimized for performance on mobile devices, and contextually aware of the platform in which they are executing. We also get access to native APIs, all of the APIs, by virtue of, 1,100 or more different plugins that are developed and maintained, not just by individual contributors within the community, but also from large enterprise organizations like Microsoft and Adobe and Google and others. And because all of the assets are packaged with the application and then installed directly on the device, you have support for offline scenarios. So if we're working inside of, fickle Wi-Fi inside of a conference, that's okay. We can still use our application offline because all the assets are local. Sound good? Cool. All right. So let's bring it back to the code. Bring it back to the code. We're gonna do it. All right. Number 6. Engage. All right. So let's dive into the anatomy of a particular view, right?
Yep.
Now, our views, as we were kind of starting to say earlier, are largely contained inside of the pages directory within the app. Think of a page just as a collection, or any one of those views, the session list, right? Which is right here. Actually, session list. Where's my sessions? Schedule, there we go. The schedule, or a session detail, or the map page. Each one of those is a view. And we're going to start with one of the simpler views. Let's actually start with that login page that we were looking at earlier. In fact, lo and behold, I've got it open already. Good for me. I prepared.
So the login page here, we have the basically the TypeScript code to make our login page do things. And basically that is they click, log in. We actually generate and actually make the login call in the backend. So it's a very simple controller for our page. But this is TypeScript, and TypeScript is basically modern JavaScript that we can use today. So if we look at the top of this file, we see a bunch of import statements. We are able to pull in different classes from the rest of our application without polluting the global namespace. We're getting exactly what we want, and we can access them immediately in our app.
Yep.
And below that, we have this @ page.
Funny little symbol here. This guy right here, right?
This is one of my absolute most favorite features in TypeScript. This is a kind of a JavaScript future standard that lets us add metadata to our classes.
This is called a decorator, for those who aren't already familiar with it. And decorators essentially allow us to separate out our concerns between the business logic in the class, and then to decorate it like, I think the analogy I was using the other day, it's like you took a fir tree and you added some decorations to it, it became a Christmas tree. Now it's still a tree, it's just a specific kind of tree, right? And so that's exactly what this decorator is doing here. It's adding additional functionality to make our class kind of tailored to a particular use.
Yep, so we have our login page, but it doesn't really need to care about what it looks like underneath. There's a good, clean separation of concerns through this metadata that's been added with the decorator.
Yeah. And so here we're assigning a template. And for that, let's take a quick look at the template itself. That's embedded in the HTML file that is paired with it in the same directory, login.html.
Yeah, so if you look at this template, if you're a web developer, it should look very familiar to you. It's pretty much just HTML. We're using some class attributes, et cetera. And we have a few custom HTML tags here, these web component sort of things.
Yep. So here's one right here, Ion navbar.
So Ion navbar, pretty naturally influences what the navbar on the top of the app looks like for this page. So in this case, it shows the menu icon, but also shows that you're on the login page in the header bar. And the nice thing is this will adapt to be left aligned on Android, center aligned on iOS, et cetera. So it adapts to the platform.
I think what's cool about this is that these web components, each of these already exists in the native world. There already is a native Swift control for a navbar and a native Android control for a navbar. These are things that already exist in the native world that just did not have an equivalent in the div, span, emphasis tag world of HTML. And so what we're really doing with this is we are expanding the world of HTML tags to bring in controls that are built specifically that already are natural in the mobile development world. But we don't really have to change the way that we develop.
Exactly. We always kind of looked at the browser as this blank slate. It didn't prescribe any sort of user interface, and it kind of worked on everything, but it was really up to you to customize and actually target the platform that you wanted to go after. So we took the opportunity to build a set of mobile components on top of the browser to do just that.
I will actually, just so we can compare it here, there we go. Log in. Here's each of our buttons. Here's each of our buttons. Fairly simple stuff, right? All right, let's take it back to the class, because there's some cool stuff happening in here.
Yep. So we've got a constructor where we're actually injecting additional dependencies that this class needs from Angular and the amazing typing power of TypeScript.
Yeah, now I want to queue up something here about the way that dependency injection is happening within Angular 2.0. Now, as almost everyone here I'm sure knows, between Angular 1 and Angular 2, the Google team adopted TypeScript. And when they did, they dramatically improved the tooling story for all of you. They did this because in the old Angular 1.x world, you'll remember that dependency injection was a relatively verbose exercise. And when you injected a class, it was essentially injecting a string that did a kind of a pattern match there. And here, in the Angular 2 world, your dependency injection is actually a strongly typed list of classes. Now, that's really important because it now provides a direct pointer back to the original markup that defines, or the original imperative code that defines those classes. So whereas in the Angular 1.x kind of era, things like IntelliSense were our best guess based upon static analysis of the code for what methods and properties were available off of that class. Now we can provide much more accurate, much more reliable, and much more performant IntelliSense because we've got a pointer directly back to the method itself. So let's actually see what that kind of means in practice. So now I can say this dot user data. Start to get IntelliSense for it immediately. And now I get a list of all of the different methods that are available off of my user data class. All of this, it has the absolute certainty of being accurate because it's pointing back to the actual class definition itself. That is super, super powerful and super helpful as you're kind of winding your way through code, especially code that might be part of a larger application where you may not know the exact anatomy of all the classes that you're consuming. Now, there's more that you can do here by virtue of this being strongly typed, right? So, for example, if I want to navigate around my classes and kind of get a better understanding of how things are actually put together. Let's say that I want to, for example, I want to understand what's happening with that login method. And let's say, in particular, I'm not so concerned about actually changing the method. I just want to know what happens when a user logs in. I can right-click on that. I can peek definition. And now I get an in-context view of where that method is actually defined so that I've got a pretty good idea now that, oh, hey, this login method, oh, it's just a couple of lines of code. Now I understand what happens there. Now, if that's not enough and I actually want to be able to go back and edit the file, I can use a lot of the same features that many of you might already expect out of Visual Studio IDE to navigate directly to the code. So I can do things like go to definition, right? And it'll jump me directly over to userdata.ts where that method is defined. Or if I want to go back over to the login page, and because this is strongly typed, I can also do things like right-click on it, and I can rename the symbol, which will refactor globally throughout the entire application without me having to do the uncertain work of a find and replace that may or may not actually be replacing that exact method. So that's super, super powerful, super helpful. All right, so we've seen a little bit about the kind of TypeScript editing experience and the IntelliSense experience. Let's actually spend some time debugging, which I don't know about you guys, but that's where I end up spending a lot of my time somehow, right? So I already happen to have the application deployed over here to my Android device. In this particular case, I've got I'm gonna move this guy over to here and here. I've got a Nexus 5 that is tethered to my device, and I'm projecting it onto this little kind of screencast kind of thing. So we're actually going to bring up our build schedule here. All right. Now, while we're here, it's worth noting we spent a lot of time. Oh, I can't actually click on it. I have to. It fools you like that. We spent a lot of time earlier talking about the contextual awareness of UI controls within Ionic for mobile apps. And this is a really apt moment to point that out. We've got an iOS device and an Android device up side by side. And here, I think it's worth noting some of the dissimilarities between the two implementations.
So obviously, iOS and Android are not the same. The UIs are not the same. And users have different expectations about what the apps look like on each platform. So Ionic takes the core paradigms, the UI paradigms that users are used to, and automatically adapts your app to match those. So if we take a look at the iOS app, we see the classic tabs on the bottom of the average iOS app. We see the segment control in the toolbar. We see the search box, etc. Yep. If we look at the Android app, we have what is really just a kind of similar looking branded experience. So we have our build blue, etc. But we're using material design concepts now instead. So we've got ripple effects. We've got tabs that feel like the material design tabs. We've got a drawer menu that is the actual kind of slide out drawer that we expect to see on an Android app. And all of this happens automatically, but it also is the same CSS and HTML components that you can customize if you really want to have fine-grained control over the experience.
Yeah, remember that back over in login.html, where we actually defined this UI, it was just through these abstracted away web components. And so we didn't have to go back and do the hard work of actually redefining the HTML, the CSS, that kind of sort of shifts those objects around on the page to customize it for the native-like controls for each platform. All right, cool. And actually, it's also worth noting the, I don't know if you mentioned this, but the ripple that you get in some of these little micro interactions that happen inside of this. Let's see if I can actually, yeah, see the ripple that I get there? Woo! Right, cool stuff. All right, so here's what we're gonna do. Let's actually, I promised debugging, so let's do that. So as many of you may know, Visual Studio Code really started its life as a kind of, its first primary use case was as a node authoring tool. And node authoring requires node debugging. In other words, a JavaScript debugger. And so with the Cordova Tools extension for Visual Studio Code, what we've essentially done is reappropriated that same debugger for debugging against mobile devices, whether those are emulators, tethered devices, or even browsers. So what I'm going to do here is I'm going to head on over to my debugger, and I've got a list here of a bunch of different options that I can do. Hopefully that's visible on screen, but you'll see that I've got run Android on device, attached to running Android on device, on iOS, etc. In this particular case, we're going to attach to the instance that we've already got running in our Nexus here. Just hit play, and you'll notice that down here on the bottom on our debug console, let us know that it's already attached, and we know that it's attached because the kind of toolbar at the bottom has turned orange. At this point, I can start to set breakpoints and inspect my code from directly within the IDE. This is a significant departure from the way we would usually work inside of maybe a Chrome developer tool or an IE developer tools, where our debugging actually happens in the browser against the compiled version of the JavaScript or the compiled version of the CSS. And here, we're able to actually have the luxury of setting breakpoints against the original definition of the TypeScript command pre-compiled, so we don't have to make that logical leap between the compiled code and the pre-compiled code, which can often look very different. So let's actually do this. We're going to do this on another page. We're going to do it on the schedule page. So let's bring this guy up. Schedule. And in schedule at TS, there's a moment here where we add favorites. And so I'm just going to add a little breakpoint right here, right where I add a favorite. Oh, this guy's already added in here. Find one that hasn't been added yet. Oh, you guys can't see. Here you go. So I've swiped left to get my favorite button up. I'm going to tap it. Favorite added. Uh-oh, did I not put it in the right place? Am I still attached? Add favorite. Here, we're going to detach and then reattach, just in case. All right. Set a breakpoint here. Swipe right. Oh, heavens to Betsy. I'm not hitting my breakpoints. Sad day. Well, this is what happens when you demo beta software, but that will happen. So we're gonna move on. We're gonna move on. All right. So we've gone through debugging. We've gotten a really good look at what the actual kind of architecture of it looks like. I think it's probably time to move on to talk about the server-side aspect, because everyone knows every good client application is backed by a tremendous service. And so with that, Max, thank you very much.
Thank you.
Yeah. All right. So in order to see the kind of server side of things, we're going to move on over to Visual Studio. And in fact, today, let's see here, we're going to switch machines for that. Machine 8, machine 8. Let's get this guy. Wakey, wakey. All right, no thank you. All right, cool. So for this, we're going to head on over to the Visual Studio side of things. And today, we're going to really use, for most of our services, we're going to use Azure Mobile App Services that Scott just announced about a week ago now, and are available today on the Azure portal. So for this, we're going to start in the actual portal itself. I've already logged in. And our services today take care of really two jobs to one end use case. Really what we wanted to do is we wanted to enable users like you, conference attendees, to be able to synchronize your favorite sessions across devices, right? And that allows you to favorite it on your phone and then go to your desktop later on and build out your schedule. Two things are required for that. First, one needs to be able to identify yourself, right? And so we're going to be using identity services. Second, we need to be able to store all of our favorites in the cloud and synchronize them with the local device just in case it's offline. And so for that, we're going to be using Azure Easy Tables and some online-offline sync. For this, all I've done is I've created an account, and it gives me a nice little URL here that is specific to my app. Every app service has its own URL, and so we'll be using this as the identity of our service throughout the demo. From here, to configure identity, which is really the first step, we're going to head on over to authentication and authorization. Configuring identity services is really just as simple as flipping an on-off switch and then getting the keys for each of your providers. So in this case, we've already turned it on. We happen to have configured Facebook, Google, and Twitter, but we could have also configured Azure Active Directory for more enterprise-like scenarios and Microsoft for everyday being awesome scenarios, right? Configuring each one of those identities is as simple as providing the token and the app ID for each one of those. I will be taking this app secret away after this demo so that no one has access to it anymore. No pirating our accounts, folks. And so that's all that I had to do. That's all that I had to do in order to configure it. Now, from a user experience perspective, let's actually make this work by, I think, if I'm not mistaken, I've already deployed it here to my Windows device. I will say allow screen projection here. Indeed, I have. Now, notice here again, we are contextually aware and have modified and updated the design yet again. Now it's looking a little bit more Windows-like. We've got kind of the more Sego UI type font up top. We've got more squares up top. But for this, we're going to log in because that's what we care about for the identity portion. In fact, we're going to log in with Twitter. In this particular case, I will hide it again. I know you're all nefarious pirates of identity. Okay. Ryan, J-S-A-L-V-A. Not visible, right? Sweet. I hope I remember my password. All right. Now, Jeremy, who's sitting in the audience, because I've got two-factor authentication, is going to tell me what text just came to my phone. Got a number for me? Not yet. This is secure. Oh, here it is. All right. Twitter did its job. 089824. Okay, so now we are logged in. We have identified and authorized this app to interact with Azure App Services on our behalf. Now, that's what the user experience looked like. And you would imagine that in order to implement identity services for multiple different providers, Facebook, Twitter, Microsoft, Azure Active Directory, that this would be a lot of code. And this is where I'm really, really pleased to say it's not, right? So the actual method that does the login happens here in user data. And just so you guys know, the user experience started with us clicking on that button, and then user data, it gets redirected to the handler, which is login, or the service provider, which is login. So go to definition on that one. Within user data, that login method is really, really simple. I'm not going to kind of belabor it, but just to walk you through the code quickly. Setting a property to an instance of the Azure Mobile Services client. Here, we've provided it with that same URL that was provided to us back over here. And then, using a promise provided through the magic of TypeScript again, an ES6 feature available in ES5 because it's been compiled down to ES5 through TypeScript. We're going to make an asynchronous call. That moment where we made the asynchronous call, that's when we hit that login button, and it transferred over to the Twitter kind of like login page with the username and the password, right? And we're just going to hang out. We're just going to wait as an application until the identity service returns back a negative or a positive response. And when it returns back a user identity, we're going to farm that out to this login response method. So all of our identity sort of negotiation was taken care of with these 2 lines of code. From then, we went on to pass it on to login response that, again, just got a Windows Azure user object back. That user object, we don't do a lot with it. We record a user ID so that we can store that user ID back into our list of favorites in the cloud. We provide a nice little convenience method here to say, yep, logged in, true. We're now going to propagate an event to tell the rest of the application the user has now logged in. You can react to that however you want to. And so the rest of the application can maybe change it so that it says, welcome back, Ryan, or do any of those kind of good customizations. And then finally, we're going to sync our favorites. So all of identity handled there in just 2 little compact methods. So that's just the beginning of our story, though, because now we actually need to do the synchronization across our local device and the cloud. So let's take a look at what's actually happening up in the cloud. We're going to stay within our Azure portal, and then here we're going to navigate up a little bit into our mobile services, and we're going to use easy tables. Easy tables, well, they're easy. There's not much to them, in so much as it's essentially a remote table that lives in the cloud that you can access via asynchronous calls in your client-side code. So I've just created a single table for this application. It's called favorites, strangely enough. I'm going to manage the schema for that so you can get an idea for how it's put together. There's only a few columns here, some normal stuff, time created, date created, last time updated. The really important stuff here is just that a user ID to associate it with one particular user, and then a session name in order to identify the session that they favorited. I also have things in here like a deleted column so that I can mark when they've removed that favorite from their session list. But other than that, that's all that I really need in order to keep a list of retained bookmarks, if you will, in the cloud. Now, I'm not saying that this is the paradigm of complex engineering from a table perspective, but it does the job. What I really want you to pay attention to here is, and I genuinely, as a human being, think that this is cool. I'm going to go to definition for sync favorites. And I don't want you to get too caught up in the actual algorithm that we're using here in order to differentiate cloud favorites versus local favorites and to merge the two. What's important here is the syntax that we're using to actually query that remote table. What we've got here, so let's kind of walk through it a little bit. So I create a local property called this remote faves table. That is an instance of this thing called this client get table. So I now have a pointer directly back to a data source that is in the cloud from within my client-side code, right? I don't have to worry about actually bringing all of that table down locally first. I can just point to a remote instance of it. And now I'm going to use asynchronous calls using a SQL-like syntax to actually query that, right? So this remote faves table, where? Simple SQL syntax, right? And I've just here provide user ID so that I can pull back only those favorites for that particular user, and then I'm going to read it, right? That just then sends a call out to Azure. Azure's going to return back asynchronously a kind of all of my data, essentially as a JSON object, and then with that data, I can start to perform my kind of matching to see what is new, what is deleted, what needs to be synchronized locally and remotely, right? And so that I can use like what amounts to just simple SQL syntax in a JavaScripty way, this weird kind of, this weird bride or Cinderella child between SQL and JavaScript, makes for a really elegant syntax. All right, now that gets us through identity management. That gets us through kind of synchronizing our favorites as well. But there's one piece that I haven't gotten to yet that is really one of the shining moments of JavaScript apps, and it's this. And actually, I'm gonna read here from the developer agreement. This one happens to be from the Apple Store, but there's a similar clause in both the Google Store and the Windows Store. I brought mine so I can do it verbatim for you here. Section 3.3.2. An app may not download or install executable code. Interpreted code may only be used in an app if all scripts, code, and interpreters are packaged in the app and not downloaded. So what that means is that you can't update your app without resubmitting to the store. I'll continue on. The only exception to the foregoing is scripts and code downloaded and run by Apple's built-in WebKit framework or JS Core, provided that such scripts and code do not change the primary purpose of the app. If I may translate the legalese here, what that really means is that JavaScript-based applications can be updated without resubmitting to the store, so long as you're not changing the purpose of the app. So if you've got a bug fix or a feature update that you want to make, you don't have to wait 3, 4, 5 days, 2 weeks for that app to wander through the update process. One can simply publish and update and rehydrate that app on your own time, on your own schedule. And so we're going to actually kind of go through that today and look at what that looks like. For that, we're going to be using a service called Microsoft Code Push. Code Push works for both Cordova and React Native apps. And what it essentially does is it's an Azure-hosted service. What you'll do is you will publish your app. It will upload a zip file of all of your web assets to Azure. And then the app itself will, at whatever time you decide, maybe it's on startup, maybe, as in our case, when you click a button, it will ask the server, do you have an update? The server will respond, yes. It will download that update and rehydrate the app with your brand new, beautiful, awesome app. So let's actually do that. All right. So in this particular case, keen eyes may have noticed that, let's see, wrong window here. Wakey, wakey. May have noticed that if I log out here, there is a, oops. Come back here. If I sign out, there is a sign up button here. And there isn't actually a sign up page that's been created yet. We'll call that a bug, shall we? And so I want to update this app to remove that sign up page. And I want to do it quickly because it doesn't exist. All right? So here's what we're going to do. We're going to go to app.ts and just quickly remove that option. Okay, save. Make sure I don't forget anything. I got a little checklist here. All right. So now that it is removed, we're going to do a quick git status. Oops. All right. App.ts has been changed. Git add dot. Okay. Git status. Good. Ready to go. Git commit m removed sign up. So all that we're doing here is pushing all of that code up to our Visual Studio Team Services instance. Jeez. Oh, I got to sign in. Run config global user.email. All right, cool. We're good. All right, so now that that guy is up there, I can go over to Visual Studio Team Services. And from within Visual Studio Team Services, if I go to Builds, you can see here that we've got a bunch of build definitions. And in fact, the one that we're going to be using is build 2016 Android. And you'll see that we've got a bunch of them that we've already previously executed. Some of them succeeded, some of them failed for various and sundry reasons. Let's actually kind of look at what the definition looks like first so we can understand what some of them look like. So I can just edit. All right. So hearken back, if you will, to 30, 40 minutes ago when we were talking about what the actual build process for Cordova looked like. Well, NPM is used to actually acquire all of the plugins, and then we need to run a gulp task. And the gulp task will essentially call out to execute our SAS compilation. And then once our project is nice and prepared, gulp will also execute our TypeScript compilation as well. Then once all of that's done, we need to do a Cordova build. In this case, we're going to build for Android. And then we've got this code push release task that's right here, right? And that code push release task is basically going to take the output of that package and send it out to the Azure Code Push service so that our app can then rehydrate it again. So in this case, we did it for Android. Let's actually see if this guy is queued up here. So go back to builds. Hasn't been queued up yet. That's OK, or maybe it even completed. No, that one's 16 hours ago. So this guy should queue up any second. In the meantime, I happen to have, because I know that those builds can sometimes take a little while, I happen to have already queued up a code push instance right here on the Android device. Everybody's phones are going off. It's that time. All right. So here on my Nexus 5, I'm going to head on over here to the About page. We've already created a little button that is check for updates. I can hit check for updates, and now that code push package is already ready for me. Would I like to update my app? Yes. At this point, it's going to suck down from Azure. Say allow. It's going to suck down from Azure the new HTML, CSS, JavaScript, image assets, all of that, and it's going to rehydrate the app with all of the changes. Frankly, I don't remember if on this one I removed the sign up, and in fact I did. I removed the sign up. There we go. So we have just effectively updated our app without having to resubmit to the app stores, and this gives us the ability to kind of release at our own cadence, which is super, super cool. Yeah, right? Totally. That's totally worthy of applause. I agree. I agree. All right. So let's advance through this here a little bit. So here at the end of it, let's ask ourselves again. Can the web reinvent itself again? Can it remain relevant? And I think there's promise here. I think that we can do it. I think that through the innovation, not just of Microsoft alone, but the ecosystem that constitutes the web, we have the potential to achieve truly great things, especially in the realm of cross-platform development. And that synergy, God, I use the word synergy, that synergy can be accomplished when the frameworks and the tool makers work together. We can get performance obsessed again. We can deliver stuff that is fast, that is snappy, that is responsive, that is fluid, that feels like butter under our fingers. We can deliver user experiences that are contextual to the platforms where they are used. We can do that in a way that allows us to take our code between lightweight text editors like Visual Studio Code or Vim or TextMate or whatever, and then bring it on into Visual Studio and have it still work. We can do that because we've got a common understanding of where we are heading as a technology, as an industry. And I believe that we can go there faster because we've got compilers and languages like TypeScript that are helping advance the standards to allow us to use features of the future today. And last but not least, I believe that the tooling we provide, if we can provide it across all of the different platforms, right? If I don't have to learn Xcode for iOS and Android Studio for Android and Visual Studio for Windows, if I can use the exact same tool to deliver to all the platforms, to all the targets, I will be more effective as a developer, I will be worth more as a developer, and I will be able to reach more audiences. And that's really what it's all about. It's about trying to get your creation out there into the hands of users. So with that, thank you all very, very much. Truly appreciated it. This is what you can get today. VS Code, Visual Studio 2015, tools for Apache Cordova. There are Ionic templates to come with it. Highly recommend you go check it out. Code Push is available today. And there are a lot of sessions happening at Build that you may want to go check out. Please, go grab them. And do not forget, please do not forget, I thrive on your feedback. I truly appreciate it, and I read and take to heart every single session evaluation that you guys write, so send them out. Enjoy the rest of the conference. I will be available for questions afterwards. Hang around.
Ryan,
Yes?
feedback for challenge points.
Feedback for what?
Session feedback.
Ah, yes. Feedback. So, in the back, there is a gentleman holding a flash voting sign. He wants your opinion. This is our user research team at Microsoft. These guys are rock stars. These are the David Bowies of Microsoft. And they are more awesome because they take all of your feedback and channel it into the product. So please, please, please talk to them and let them know what tools you're using, how you're using them, what you're successful doing, and that will make its way back into the product so we can make it better for you.